how do you design your rocket?
That's a difficult question. So it's really an iterative process. First, we start with a goal, so the main requirements of the rocket, which in our case, well, were to have a rocket which was as cost effective as possible, because budget is limited. So the key points were to be reusable and reconfigurable. That means that our rocket is capable to reach apogees of 1 kilometer or 5 kilometers or more. Of course, in this range, we have the 3-kilometer target, which is the one of the competitions, which is the most important one. So we have a modular design with components that we can interchange to have different mission objectives, such as system testing. We want to test the avionics. We want to test the recovery system. We want to test the payload. We want to have some specific acceleration at the beginning, or we want to have a lower one. We want to have a maximum velocity, which is supersonic or supersonic. We can do that. We can modify our rocket without exchanging too many components, so we save a lot of money, and we can do it really easily thanks to our design. Another point is of course, reusability. We launched the rocket in Germany in April, and we reused the same rocket at Spaceport. We plan to reuse basically the same rocket also at Europe with some components changed, thanks to the recovery system, of course, which is a pivotal point of all rockets. So we need to have perfect recovery all times to retrieve the rocket. Another point is, weight saving. So sometimes, most of the times, weight saving and cost saving, they don't get along really well. In our case, basically weight saving meant cost saving, because our rocket is extremely light. Basically, we have a rocket which is, without propellant, it's a little more than 4 kilos, and then it can hold 4 kilos of payload. So it's really lightweight. Why do we want a rocket which is really lightweight? Because we have cost propulsion. Of course, we want to have a motor which is the less powerful as possible to be also less expensive. We saw at Spaceport America, many teams, we were basically bragging about the size and the weight of the rockets. I think it's the opposite point. We want to make rockets as lightweight as possible, and while being able to carry a heavy and scientific payload. So I think that's the main point of the design. And yeah, the design was really iterative. So we started designing the structure, and then we went to do weight saving. We saw the possible alternatives for each component, keeping in mind the costs and everything. And yeah, in a really short time, we designed the rocket and we built it and we launched that. I can say that our design has also some pretty good technology in terms of additive manufacturing, because basically all components of our rocket are realized in 3D printing in advanced materials, which are provided by the university, luckily, with the exception of just 2 components, which is the nozzle disc and the tip, which are realized in aluminum. And this technology was also really helpful for the fins of our rocket, for which we were also awarded a prize for innovation at Spaceport America Cup.